Welcome to our webcast. Today we're talking about multi-channel fulfillment, how PUMA created the ideal system for today and tomorrow. I'm David Maloney, the editorial director of DC Velocity. The e-commerce boom has transformed modern supply chain operations, requiring companies to be faster, more efficient, and more agile than ever before. Successful retailers know that to keep up with this Amazon effect, they must employ the right mix of data, software, and hardware. The challenge is knowing where to start. What data should be analyzed? What software can manage everything from inventory to equipment? What automation technologies are the best fit for your storage and throughput requirements? How are other retailers successfully updating their order fulfillment operations? In this webcast, we'll address these questions to help you achieve faster e-commerce and retail fulfillment within a single facility. By understanding your key data points, we will be able to better select the right mix of material handling automation and design the ideal multi-channel fulfillment center for today and tomorrow. Our webcast today is presented by Bastian Solutions, a Toyota advanced logistics company. As a system integrator, Bastian Solutions seeks out leading technologies in both material handling equipment and information systems coupled with proven operational strategies. Bastian's experts combine the powers of scalable material handling systems, innovative software, and custom automation engineering for complete, unique solutions. For more information about Bastian, visit bastiansolutions.com. We have just a few announcements before we begin. On the screen, you'll see some tips to help you connect and participate in the webcast. Follow these tips if you need any help. The webcast is designed to be interactive between you and our presenters, so later in the program, we'll have a question and answer session to allow you to ask our presenters questions relevant to the topics that we discussed today. You can participate in the Q&A session by asking questions at any time during the webcast. You don't have to wait till the very end to get your questions to us. Just ask away during the course of the webcast, and they'll be ready for us when we get to that section. So just type your question into the text box that's located on the bottom left of the console. Click the Submit Question button, and we'll get to as many questions during our presentation as we can. The slides will advance automatically throughout the event. If the slides are not advancing, we encourage you to press the F5 key or Control-R on your keyboard to refresh your console. We also recommend you disable any of your pop-up blockers. If you're experiencing any kind of technical problem, please visit our webcast help guide by clicking on the help link below the media player. And now let's get on with our program today. Allow me to introduce our presenters. Matt Cooper is Director of National Accounts at Bastian Solutions. Matt has more than 18 years of experience in the material handling industry. He's handled a variety of different system projects and technology, including high-speed sortation, pick modules, good-to-person, and pallet handling systems. Derek Cribley is Director of Advanced Technology at Bastian Solutions. Derek is responsible for all aspects of the company's integration of advanced and complex technologies. This focuses on goods-to-person solutions, automated storage and retrieval systems, automated guided vehicles, autonomous mobile robots, and shuttle technologies. Melissa Curry is Director of Operations at Cartage NFI. Melissa currently oversees a dedicated distribution center that covers over 1 million square feet of warehouse space across 4 buildings for PUMA North America. Prior to this role, Melissa has been in the logistics industry for almost a decade with Cartage, working on continuous improvement projects, as well as opening and running a customs examination site, which is now the largest in the Los Angeles region. And lastly, Marvin Logan is Vice President, Consulting Services at Bastian Solutions. Marvin leads a group of very talented engineers who have worked with leading companies in industries that include apparel, consumer goods, e-commerce, electronics, publishing, biomedical, and food and beverage. Marvin has over 30 years of operations and engineering management experience. Welcome to all of you, and thanks for joining us today on the webcast. At this point, I would like to turn the floor over to Matt to begin today's presentation. Matt?
Thank you, David. I'm Matt Cooper, and I am the Director of National Accounts with Bastian. My team and I work to develop and propose automated material handling solutions for our clients. Today we're going to discuss multi-channel fulfillment by focusing on retail trends that are impacting fulfillment today, the technologies that enable multi-channel fulfillment to be possible, We'll touch on a case study with California Cartage and PUMA in Torrance, California, and then discuss data that we need to better understand before we get into the automation world. So what trends are impacting order fulfillment? Well, personal commerce has changed remarkably over the past 300 plus years. From traveling salespeople with their wares on their person to retail stores, catalog sales, and now internet sales. Sears started the remote sales with their catalog in the late 1800s to allow all people access to consumer goods. This allowed people in rural areas access to all the same products as those in more urban areas with traditional retail outlets. Today's catalog orders or e-commerce orders allow people to shop for almost anything from almost anywhere and take delivery almost instantaneously. So how prevalent is e-commerce? In 2018, the third quarter results show that e-commerce represents 40% of total retail growth. Companies have jumped into the e-commerce pool feet first. An unsurprising trend considering the overwhelming revenue driven by online sales. In fact, Shopify expects worldwide consumer e-commerce sales to grow to $4.5 trillion by 2021. And not to be outdone, business-to-business online sales have grown steadily over the last few years. In fact, B2B e-commerce is growing at a compounded annual growth rate of 7.4%, according to Forrester Research. These sales are now on track to hit $1.2 trillion by 2021 and will account for more than 13% of all business-to-business sales in the U.S. So Forrester Research sets the U.S. online sales to grow 13% year over year, which is 5 times faster than projected offline sales growth. Some reasons behind this projected sales growth include young professionals, millennials, that seem to have busier and busier schedules, trying to achieve a perfect work-life balance, reduces time to shop in a more traditional way. Traffic in larger urban areas is making travel more difficult. More and more of the U.S. population is centering around larger metropolitan areas, putting increased strains on existing infrastructure. Overall convenience. As population continues to be more comfortable with technology, there is less resistance to adopting the e-commerce method of purchasing products. And finally, technology continues to improve. Faster and more readily available Wi-Fi and data streaming mobile devices allow for access to the internet all the time. Ability to order products while on public transportation, waiting for an appointment, and even in bed before falling asleep. So what is helping to perpetuate this change? The Amazon effect. The Amazon effect is the impact that Amazon has had within the retail world, beginning with the service Amazon offers to its customers and ending with its impact to the competition. The Amazon effect is the ongoing evolution and disruption of the retail market, both online and in physical outlets, resulting from increased e-commerce. The name is an acknowledgement of Amazon's early and continuing domination in online sales, which has driven much of the disruption. So what are nimble retailers and third-party providers doing? Well, they are realizing that the customer experience is paramount to winning and keeping business. It's driving retailers, e-tailers, and third-party operators alike to pursue better order fulfillment solutions. As retailers are forced to shift to experience-based brick-and-mortar solutions, the pressure to distribute product has changed to smaller, more focused volumes. The ability to handle order fulfillment is now pushing forward as a service that needs to have increased priority and quality. The delivery itself is a single source of competitive advantage that makes or breaks the customer relationship. Amazon's offering include delivery service level agreements that are at or near the best in the e-commerce retail arena. The Amazon effect has also created a dramatic change in the carrier business. Loads are smaller and in greater frequency. The large carriers are increasingly finding competition for their routes. Distribution operations are increasingly driven to locations that support transportation solutions to deliver to the entire country more effectively. From the material handling standpoint, retailers and third-party operators are making changes there too. First, retailers are employing strategies to address the shift in product volumes. Order sizes have decreased and the destination counts have exploded. The omni-channel order fulfillment approach must effectively handle orders based on the destination and the customer. For brick and mortar locations, the retailer must find a delivery method that effectively aids stocking or storage in store for smaller volumes. External customers must be delighted with the delivery. Handling methods are being coupled with technology to enhance their quality. This includes managing things like order accuracy and packaging that will help drive customer satisfaction. Including information that can help improve the delivery and support the not-so-accurate delivery is a must, such as detailed order information and easy methods to return unwanted items. The resulting effects of these pressures have moved the industry toward equipment and designs that service increased number of small orders with distribution and fulfillment centers. These include the introduction of new picking technologies like Perfect Pick and Autostore, as well as robotics. Solutions are utilizing more technologically advanced methods to control and complete their processes, including sophisticated warehouse execution systems. The result of this speed of delivery pressure has been the advent of omni-channel fulfillment centers across metro areas for larger retailers and third-party operators. These centers provide strategic proximity to the customer base, enabling a competitive delivery. They can also work with retail store sites to support the buy online, pick up in store, and return in-store services. So now I'm going to pass to Derek to discuss the technologies that support these distribution center changes.
Thanks, Matt. Good afternoon. I'm Derek Cribley, Bastian's Director of Advanced Technology, and I'm going to cover some of the technologies supporting today's multi-channel operation. Before we get into the specific technologies, I wanted to quickly review how the picking technologies are evolving. The older person-to-goods technologies, where the picker traveled to the goods to complete the picks, served the earlier warehouse operations well. But the increase in the number of SKUs and the split case picking drove the development of improved goods-to-person technologies. These technologies allow the operators to stay in one location, working in a highly effective picking configuration. This can allow them to achieve up to 6 times the productivity of a person-to-goods methodology. There are also significant advances in the capabilities of robotic pickers, which will further evolve the order picking operation with goods to robot. There are a few supporting technologies that can be employed across a variety of methodologies. These technologies help improve the efficiency and accuracy of the picking operation. Each of these supporting technologies has its advantage that should be considered based on the application. For example, RF strengths are flexibility and accuracy. Voice picking builds on the flexibility of RF and allows for a hands-free operation. Unlike the first two technologies, like directed and display technology are installed at specific pick input to locations, so they have a cost per location that needs to be considered. Lights and displays permit a hands-free operation with very high productivity in smaller zones. And finally, the gaming industry has driven significant advancements in augmented reality technologies that are making their way into warehouse operations. These technologies combine the advantages of RF, voice, and light-directed operations. Pick-to-cart is an attractive legacy solution for simplicity and low capital investment. The picking rates are usually in the range of 30 to 100 lines per hour. Typically, either a cluster or batch picking methodology is employed to allow the operator to fulfill multiple orders per pick trip. A zoning methodology is also usually employed to reduce the operator travel. The technologies deployed for pick-to-cart is usually kept pretty simple, with most using an RF or voice technology to direct the operators. Light-directed put-to locations on the pick carts can also be added to increase the picker productivity. The solution tends to be limited to lower volume each pick operations for cluster picking. Zone batch picking can be used for higher rates, but requires the deployment of sorting technology to consolidate the orders. Certainly, as the SKU count increases, this becomes a less viable solution. Pick modules are a common feature of many conventional warehouses because they make the picking process more efficient by concentrating as many SKUs as possible onto a smaller footprint. Pick module design is a science in itself, and you'll see many variations throughout distribution, employing a variety of storage media and supporting technologies. Most modules use zoning, where operators are assigned specific areas of coverage, oftentimes with a pick and pass methodology. The transportation of products is typically provided by conveyors, but pick modules for slower moving products can also employ a pick-to-cart. The mobile autonomous robot is one of the fastest growing technologies being deployed in distribution operations. The growth has improved the capabilities and reduced the costs. The robots have been deployed primarily to reduce the operator travel by routing the pick and replenishment bins to the various zones. The result is typically a doubling in their productivity. The speed to deployment and the ability to implement in existing conventional operations are some of the other advantages of these solutions. And compared to a conveyor-based solution, the robots are more flexible and scalable. Finally, there's also been some success in the deployment of mobile robots that are equipped with multi-axis arms that can pick items without an operator. We see this as the future robots-to-good evolution. Although goods to person is a relatively new trend in the multi-channel distribution operation, the concept has been around for some time. Carousels, vertical lift modules, and automated storage and retrieval systems have been utilized for decades. Carousels are typically arranged with multiple carousels per pick zone, and they provide a relatively dense storage with no aisles. You can expect rates between 100 to 200 lines per hour. Vertical lift modules have a small footprint and a high vertical. Multiple VLMs can be positioned side by side. They're great for small parts and very slow-moving SKUs. Typically, rates are 45 to 60 lines per hour. Finally, mini-load, ASRS, is really a miniaturized version of the larger pallet ASRS. It's geared towards carton and tote handling. Typically utilize a single crane per aisle and achieve rates between 100 and 150 lines per hour. Multi-shuttles were developed in part to support the higher rates needed for e-commerce fulfillment that the mini-loads could not meet. A multi-level racking system stores the product, typically in totes, and provides the tracks that the shuttles operate on to access the products. The shuttles are typically assigned to a given level of storage, and the lifts move the loads to and from the storage levels and the pick station conveyor. For low-rate systems, a shuttle can move the shuttles between levels. In higher-rate systems, multiple shuttles work together on a given level. The tote lift is the ultimate bottleneck for this system, with lifts maximizing out at about 800 dual cycles per hour. The perfect pick is a very popular goods-to-person technology where several iBots can operate independently in an aisle to achieve very high throughputs. What is unique about the perfect pick is the iBots can travel both vertically and horizontally, which eliminates the need for lifts. Pick stations can be positioned at both ends of the aisle where a dynamic multi-order put-to-light pick configuration is deployed to maximize the equipment efficiency. The perfect pick maximum sustained rate is between 500 and 600 totes per hour. Autostore is another popular goods-to-person technology. What is particularly attractive is the tight footprint and cube requirement. It is the densest automated storage technology on the market. An aluminum grid structure stores bins that are stacked up to 16 bins tall and supports a track system where the battery-operated robots move to retrieve bins, deliver them to the ports, and then return them to the grid. Any bin can go to any port, which allows orders to be pick complete at the port and reducing the conveyor requirements compared to a system requiring a pick and pass methodology. The system is scalable by adding grid and bins for more storage and robots and ports for more throughput. The port throughput ranges from 100 to 600 bin presentations per hour. Because the process is so different from the mobile autonomous robots that were covered previously, a separate category was created to cover mobile robots used in goods-to-person applications. Kiva, who was purchased by Amazon in 2012, started the robotics goods-to-person tech revolution. But now other companies like Grenzenbach are starting to fill the gap. With this technology, mobile robots transport shelving units to and from storage locations to picking stations. The shelving units are highly flexible, storing everything from bins of small parts to hanging garments. The picking stations provide pick-complete functionality and are typically configured to fulfill multiple orders simultaneously. They can also provide a dual-purpose replenishment function. The systems are scalable with a number of robots, stations, and shelving units. Each picking station typically does between 200 and 300 lines per hour. Robotic picking will certainly be a major player in the next generation multi-channel fulfillment operation. There are a growing number of suppliers developing the technology needed to make this effective. The key vision and gripper technologies continue to improve. Collaborative robots are also playing a big role in robotic picking, as they can work alongside people. As I mentioned earlier, the Robots Are Good technology has also been successfully deployed and will be a growing player in this area. At this point, we're transitioning from picking technologies to order consolidation and unit sortation technology. Unit sortation plays an important role in the high-capacity distribution operation. The function of unit sorters in the distribution operation is to take relatively large batches of items and then disperse these items into the appropriate chute or bin, which represents either a store or customer order. The value of unit sorting lies in the ability to perform a much more effective batch pick operation under high volume operations. The savings in picking efficiency and simplicity need to overcome the capital costs of the sorter and the additional touches needed to induct and unload the product from the sorter. Unit sorters are ideal where a high volume SKU supports many orders. The put wall is a type of manual unit sortation, typically using light devices. Operators scan the items from the batch picked tote or carton. The light associated with the order needing the item is illuminated. The operator places the item in the order slot and extinguishes the light. The process is repeated with the next SKU. Lights are also used to identify when an order is complete and ready to be packed out. Similar concepts are used in the retail applications where case quantity of products are distributed to various retail stores in a put-to-store concept. The put walls can also be incorporated in the goods-to-person pick stations to allow batch picking and sorting to occur all in one touch. Put wall productivity is typically between 250 and 400 units per hour and is easily scaled, for example, by bringing on more put wall zones as volumes increase. There are three primary categories for automated unit sorters: tilt tray, the cross belt, and the bomb bay. The selection of the sorter depends upon the product being sorted and the rate requirements. The capacity of unit sorters are typically in the range of 8,000 to 30,000 units per hour. The throughput depends upon many factors, but is mainly tied to the number and location of the induction stations relative to the chutes. Induction stations for item sortation are typically manually or semi-automated, and they have rates ranging from 800 to 1,200 units per hour. I like to think of the SureSort as an automated put wall, which combines automated unit sorting with the vertical sort capabilities similar to a put wall. It uses a semi-automated induction station to load items onto a robotic carrier that travels horizontally and vertically to sort the items to the correct bin. Bins are located on either side of the sorter to increase the sort density. The SureSort can do up to 2,400 units per hour. Pocket systems use overhead conveyor technology combined with pockets to transport, store, sequence, and sort large volumes of single items. The pockets handle a variety of sizes and types of items and provides a compact means of accumulation, while the overhead sortation and staging clears the valuable floor space. The real power of the pocket system is its ability to sequence. This permits a single pack station to handle multiple orders versus conventional unit sorters needing a chute per order. Staging lanes upstream of the sortation and sequencing lanes help decouple batch picking from the sortation, which can be very problematic in conventional systems. And finally, the sorter's performance is independent from the order profile. Pocket sorters are modular and scalable, with each module typically doing about 10,000 units per hour. I now want to shift from order sortation and consolidation technology to the packing technology. The implementation of automated packaging is an essential part of most multi-channel fulfillment systems. The latest technologies in this area include automated baggers, on-demand carton production machines, and automated carton wrap machines. There is significant labor involved in conventional packing operations, which is the primary driver for implementing these automated technologies. For example, one carton wrap machine typically replaces 12 manual pack stations. But there are also significant savings realized in reduced material consumption and shipping costs. These need to be considered when selecting the right technology for your operation. I want to wrap up the technology section today with an important point. Today's multi-channel operations are very seldom relying on a single technology. Rather, most are hybrids, smartly combining many technologies. These hybrid systems take advantage of technology strength and give flexibility. The recent multi-channel application is a good example. The items were stored and picked in batches from both the Autostore and a manual pick-to-cart operation. Orders were consolidated using both put wall and SureSort technology. The choice of technology was driven by the SKU size and the movement. Thanks, and I will now turn it over to Melissa to talk about the PUMA case study.
Good afternoon. This is Melissa Curry. I am the Director of Operations with California Cartage Company /NFI. We are PUMA's dedicated 3PL. We have been their dedicated 3PL since 2006. We currently run their distribution center campus in Torrance, California, which is just south of Los Angeles. Today we're going to be discussing their apparel, accessories, and e-commerce solution. Previously, in 2006, we had worked with PUMA and installed a traditional conveyor pick-and-pass operation. The system by 2015 had been fully depreciated and could no longer keep up with both the wholesale and e-commerce volume, and we were failing on the service level requirements. We engaged with Bastian Solutions in 2015 to start exploring new options for a new system for material handling. The technologies that were explored included the Perfect Pick, the AGVs, or the Automated Guided Vehicles, the OSR, and the Autostore that have already previously been discussed. We knew that we did not want another conveyor-based pick module due to the high maintenance costs as well as high labor costs. The priorities and considerations included the fact that we were looking for a solution that would have a mix of retail, wholesale for the apparel and accessories, and all of the e-commerce shipments, including footwear. We were seeking a solution that would reduce labor and as well as increase productivity and increase throughput and meet the customer demand for receiving all the items in a single order and a single package and shipping within 24 hours of order placement, going back to that Amazon effect and the new service level that customers are expecting and demanding. We already had an existing building where our wholesale and retail footwear was being shipped out of, so we were actually consolidating into that same building from 2 buildings into 1 campus, and so we already had some constraints in the building as we were looking at these new technologies. After considering the 4 that we previously discussed, the determination was that the AGV was too high of a risk. There were no U.S. installations at the time and no expertise. Also, we felt that the space required was not a good fit for the building that we had. The OSR was also an issue with the space considerations, and then one of the larger concerns with going with that was the lift. If the lift failed, then you would lose a significant amount, and there was a concern about not being able to meet customer demands. Perfect Pick was not an option that we decided to go with due to slotting, and PUMA did not feel that they could develop that competency within the time frame for looking to go live with the project. The Autostore technology was what we ended up going with, and we felt there was better redundancy since there was no one robot that was critical to the operation. It was also the smallest footprint, and it was the best fit for the space we were looking at. So the Autostore did have a number of advantages, which was the reason we made the determination to go with the Autostore. The biggest decision factors were the high density storage for our DC, especially given high real estate costs in Southern California. There was the increased labor productivity, a significant increase in daily production and throughput, and also the fact that the system could be scaled and it was flexible to meet additional demands in the future that weren't yet forecasted. This is a layout of our Autostore that was installed in 2016. We went live in July 2016. There's 171,000 bins or totes in the grid. That was the largest installation in the U.S. at the time with 170 robots. The receiving area, there's a conveyor that offloads directly from a container. It goes through a scanner, is scanned into the WMS, and goes through the Cubiscan. The conveyor then routes the case either to the induction ports or to reserve. There's also a Q&A jackpot area if there's a bad scan or for other issue resolutions. There are 3 auto box makers that feed into the picking tunnel, where they're inducted into the picking tunnel. In the picking tunnel is set in the middle of the Autostore, and that reduces the travel time for the robots. There are 16 picking ports. We pick into batches of 4. The packing slip is printed directly at the picking port. We pick into various box sizes as well as totes for e-commerce. Those totes are sent to the auto baggers. Out of the picking port, all of the outbound cartons go through a scanner, and they're either routed to the VAS area, the auto baggers, or the automatic carton sealing and label application area. There's also a divert for another inventory or order resolution area. There are 40 VAS stations, or value-added area. There's 40 stations, which was really important because at the time we were unable to keep up with wholesale demand. There's a wide variety of requirements for the customers that include ticketing, hanging, and bagging. The auto baggers, the system was originally designed with 2, and they feed into a bag sorter. All of the retail goes directly into a FedEx ground truck, and then the wholesale orders go into a consolidation loop, and where they are consolidated onto pallets on the ground, where the goods are then routed and picked up by the customer in approximately 3 to 5 days. In 2018, this past year, we had a number of system updates to meet higher than projected demand. PUMA experienced a 50% growth in e-commerce over the last 2 years. 5 additional poly bagging stations were added. PUMA transitioned from shipping a lot of the footwear in cartons to bags, and so that increased the overall number of bags in the system to 60% of all e-commerce orders. 7 additional ports were also added, 2 picking ports in the tunnel, as well as 5 external ports along the side of the Autostore that allows for both picking as well as replenishment or put-away induction to give additional flexibility. We had an upgrade to the software that we use, which is Bastian's based Exacta software, and that allowed us to pick into particular box sizes for the entire batch and reduce the overall batch setup time, increasing picking efficiency. Lastly, we added to our reserve storage by 500,000 units. When the system was designed in 2015, it was designed for the peak e-com day. Although this is an omni-channel fulfillment center where we have wholesale, retail, and e-com peaks, the overall system was designed for that peak e-com day, which is the Black Friday, Thanksgiving weekend. In 2018, our peak e-com day was the Saturday after Thanksgiving. We shipped out 35,000 units, 25,000 lines over 3 shifts. That was e-com only. We would have been able to do more, but we actually did not have enough order selectors to pull the reserve inventory from our storage rack for the replenishment. And that was a 40% growth over the previous year. Our peak apparel accessory day on the wholesale side was 115,000 units. In our previous system, when we had the conveyor pick and pass operation, our max day was approximately 50,000 units. So the Autostore allowed us to more than double our throughput capacity. Our average e-com day is approximately 5,000 units, and our average apparel and accessories day is approximately 50,000 units. Overall, there has been a significant increase in throughput. We more than doubled our previous capacity across all channels while reducing labor costs. And most importantly, we're meeting the service levels in terms of getting out orders within the time frame that PUMA has set to meet customer demand. I'm going to pass it over to Marvin, who's going to talk about the data.
Thanks, Melissa. Again, my name is Marvin Logan, and I'm the Vice President of Consulting Services for Bastian Solutions. I want to talk a little bit about how multi-channel fulfillment solutions are designed. And first I want to give a little context to the process of selecting the right technology, and specifically the importance of conducting a thorough data analysis. The role of the integrator in material handling and automation projects is really huge. It begins with an engineering study to plan and design the optimal system for the customer's unique requirements. It involves understanding the business and operations to plan for the automation design. The design of the system builds on that planning process to deliver a concept that has a good return on investment for the customer. Then, once everyone is in agreement, the integrator moves on to an implementation role with the sourcing of the best-of-breed equipment and and systems, developing the functional specifications, project management, and then, finally installation. The integrator is also responsible for testing and training, as well as helping the customer start up and hone the system to optimal operation. That integrator role is really critical to the success of any advanced automation system implementation. As mentioned, the integration process begins with an engineering study. The integrator's consulting team must study the customer's business requirements and operations and the desired outcomes of the automation project. A 5-phase process is used for these kind of studies. It begins with defining the requirements and the goals and fully understanding the needs of the business. And then a measurement phase collects data from systems and other sources to fully measure the metrics of the operation. This data is then analyzed and models are built to determine the capacities and throughputs that will be required by any introduced business changes, including forecasted growth. The data models are used in the design process to develop these automation concepts. Technologies correctly sized based on the model outputs are chosen, and the study then moves on to a design phase. It's at this point that the layouts are created, the operational and system descriptions are developed, and really the solution starts to unfold at this point. The last step is validation. This always involves ensuring that the system will provide a good payback for the client and that all the business goals are met. But it can also include ensuring that the system itself is validated through a proof of concept or a computer simulation. A key part of the engineering study is the data analysis and modeling phase. Although the data requirements may vary somewhat based on the customer's business and its nuances, 3 data files are almost always requested. The first is an order file. This is historical, transactional, order line level data. Typically, a year's worth of data is requested to be able to see any seasonality effects. These files can therefore get quite large and require a good storage and data mining capabilities on the part of the integrator. Also important is understanding all the distinctions implied in the order data, including things like service level requirements, daily processing patterns, growth projections, things like that. The next file that is typically needed is an item master or SKU master. This file should have descriptive information about every item that was shipped or stored by the customer. Information around the item's dimensional attributes is key. If that information is not available, there are sometimes workarounds, but it is not optimal. The last file that is needed is an inventory master. Usually we would ask for monthly snapshots of SKU on-hand inventory levels. These 3 basic data files are used in the analysis and modeling phase of the study and help to answer key design questions that lead to the throughput and capacity requirements and ultimately an automation technology solution. The determination of the technology solution is determined by many factors that the data analysis helps to flesh out. For example, in a split case picking environment, the SKUs are ranked by picking velocity and broken into movement classes. This is a very simplified example. These classes can be used to start the process of looking at various types of automation that might make sense for them. Like for A movers, a lower tech solution might be a cart picking solution using voice-directed cluster picking, while a higher tech solution could involve light-directed picking from conveyor routed in a pick module, for example. High-tech solutions for B, C, and D items could include goods-to-person technologies like Autostore, Perfect Pick, or shuttles like Derek had mentioned. Of course, there are a lot of other factors that are involved, but this is one analysis that is part of the picture. Ultimately, there are 3 factors to weigh in the selection of the best automation technology. Using the data modeling and knowledge of the customer's goals, the storage and throughput requirements can be determined. Then the integrator's consulting team can select the technology solution that will best meet these requirements and provide the customer with the best return on their invested capital. Of particular interest these days is the selection of goods-to-person technologies for picking systems. There are many options today for reducing or virtually eliminating travel time that has traditionally been associated with order picking. Since this can be 50% of the time involved in picking, it makes sense to use automation to remove this non-value added effort. There are a lot of other benefits to goods-to-person systems, including increased accuracy and ergonomics, as well as improved product security and order cycle times. Goods-to-person systems are being used in many industries and multi-channel fulfillment operations. However, they're best suited to operations that have small to medium cube products And as previously mentioned, they are very good at handling B, C, and D moving items. Along with deciding which goods-to-person technology is the best fit for an operation, an integrator will work with the customer to determine what operational picking methodology is best. Regardless of the picking automation chosen, picking can be done in a discrete method, either into a tote or the final shipping carton. Or if the data analysis shows that there's a good reason to batch pick, downstream order consolidation will be needed. This could be done using manual put walls, a unit sorter, or even the automated put wall system that Derek referred to earlier. The design of a goods-to-person system is very complex, and there are a lot of configuration and design parameters that need to be considered. The expected operational growth and peak season requirements are hugely important. Also, how the technology will be used, the number of shifts, the hours per shift, replenishment, and other factors will need to be considered as part of the solution design. The adoption of advanced distribution system is no small task. It's critical to partner with an experienced integrator that can not only provide assistance with selection and sizing of the most appropriate technologies, but can also ensure the overall success of the project. The integrator should be skilled in solution design and have a history of implementation success and be able to provide 24/7 world-class support. For more information about Bastian's capabilities in doing this, there's some links there that you can click, or you can contact us at info@bastiansolutions.com. And now I'm going to turn it over to David to facilitate our Q&A.
Great, thank you very much. I appreciate it. There's a lot of information we shared today, so I'm sure that there are some questions out there. As a reminder, to participate in the question and answer session, just type your question into the text box that's located below the media player and click on the Submit Question button, and we'll take as many of those as we have time left and available to us. Okay, let me start here with a question for Marvin. What type of software platforms platforms would you recommend to best support a growing omni-channel operation? Marvin?
Yeah, so we spent a lot of time talking about technology, and a lot of that was centered around the hardware, or the different types of OEM equipment that's available. And we didn't really spend a lot of time talking about software, but really software is probably, if not the most important, it's definitely up there as far as the selection of the right type and technology to be able to facilitate everything we talked about here, especially in a hybrid solution. We would recommend a warehouse execution system typically, and for several reasons. More traditional WMS or even WCS products tend to employ a push methodology where they're pushing work in either waves or batches to the warehouse floor, and they don't always consider where the capacity is in different areas of the warehouse, and selectively choose the right orders at the right time to be able to maximize the work that can be performed at any given point in time. So typically a WES is what we would recommend.
Very good, thank you. Here's one for Derek. Which order fulfillment solutions are the most scalable so that my company does not need to replace the hardware as operations grow, but instead can just add to it with its scalability? Which of those solutions do you think work well for that?
Yeah, this is Derek Cribley again. Thank you, Dave. Well, first, I think there are two components that I think about when I hear the word scalability, and really it's the ability to increase the amount of storage capacity, and also the ability to increase the amount of throughput. So, well, that being said, really all of the technologies that we went through and presented are scalable in some manner, but some are easier than others. For example, an Autostore or a shuttle-based technology, you can increase the throughput by just simply adding more robots or shuttles to the existing storage system. And then as a comparison, others, maybe like a mini load or like a vertical lift module, you need to add entirely new units, which increases both storage and throughput at the same time. So you've got a little less flexibility with some of them, but certainly all of the goods-to-person applications that we covered have a lot of scalability in both storage and throughput. And obviously, I think I just want to wrap up with, we have been, implementing systems of this nature for quite a while, and always the expansion plan is an important part of each design. What are you going to do when you run out of capacity in the existing design? And so I recommend that as you look at each of these technologies, you consider an expansion plan and to take that scalability into effect.
Okay. Thank you, Derek. Appreciate that. Here's a question from Matt, and it's obviously the thing that everybody's trying to do today. How are companies competing with Amazon as far as same-day fulfillment and delivery? What are some of the things that companies can do?
That's a tough one, and everybody's trying to compete with those service level agreements. Some of the things that have been changing recently in distribution is we're seeing a lot of companies opening smaller, what they call metro or metropolitan distribution centers in larger urban areas or where the higher population is. And what that allows us to do is keep a smaller subset of the SKUs, your faster moving SKUs in an area that is closer to the population to help compete with some of that quicker deliveries. Another way that I've seen clients combat that speed to the customer is by allowing their existing retail brick and mortar stores to help fulfill the e-commerce orders. What you'll see is a lot of the brick and mortar stores have the inventory, and they're able to then push that inventory out to the client and have a much quicker service level than, let's say, from one of the regional distribution centers that the client already has.
Very good. Thank you. Here's another question that came in, and again, we do have a few more minutes. If you have a question, be sure to send it in to us now as we'll be wrapping here soon. Question is, how many days worth of inventory is maintained in a shuttle, like an ASRS system, and what's the method used to arrive at the data? I think that's probably a question for Marvin.
Yeah, I'll take that. So, sure. So, and I'm going to just kind of generically answer this. How much inventory is maintained in a goods-to-person or other type of picking technology, and how we arrive at that kind of information, so that kind of data. So there's different philosophies to this. We have some clients who only want to touch product one time when it comes in through receiving, and if that's the case and it doesn't oversize the system and there's a good payback for this, there are some systems that right from receiving it goes right into the automated storage or to the goods-to-person system, and it's only touched when it's then picked for an order. In other cases, we do a replenishment from another system. So receiving will then put away to a reserve area, and then we use the picking technology, and we replenish into it from the reserve. Again, we size based on a lot of different types of good on hands or days on hand. I would say are typically somewhere between 3 to 10 is kind of the range that we look at when we're designing a system like that. Sometimes we go a little bit more. Sometimes probably not much less than 3, quite frankly. We model that with our models that we build for sizing the technology. Obviously, it's going to have a huge impact on not only the storage requirements, but even the throughput requirements. So it's kind of a wishy-washy answer, but it really does depend on the goals of the customer and really how big that system can get based on how much inventory you're trying to store in it.
Great, thank you. Here's a question that came in from Melissa. Did Cal Cartage NFI need to hire expert resource pool to lift and run the solution? And what about PUMA? Did they need to ramp up in order to be able to, I'm assuming they're working with talking about the Autostore system.
Yes. So we followed the process that Marvin described with regard to Bastian, and Bastian is our integrator for the Autostore solution. So PUMA, as our long-term partner, and we're their dedicated 3PL, we engaged with Bastian, all three parties together. PUMA provided all of the detailed data for that design analysis, and then the three parties together worked on the design of the Autostore in terms of the number of ports, the sizing, the outbound requirements. We did not hire any outside expertise. Bastian brought their expertise, we brought our expertise as the 3PL, and then PUMA brought the data and their needs to provide the overall and come up with the overall solution.
Very good. Well, how long was the process? Well, how long did that take you to get everything from, to get that all integration done?
The process started in 2015, and it was approximately 15 months, depending on the scope of the solution and the lead time on the materials and things. That is a bit tighter than I think that Bastian would want nowadays, but I can let one of the Bastian guys answer that.
Bastian, any comments there? On the time frame?
On the time frame from our side, it really depends on the technology chosen and then what it takes to develop the solution. You know, Marvin talked about the different data that we need and how we need to analyze that data to help develop the solution. So I would say currently a lot of these technologies is probably a 15-month is probably a fairly aggressive time frame. It can be done a little faster, but 15 months to maybe 18 months depending on the complexity of the solution.
Very good, thank you. Here's another question, and this would be, I think, to one of our experts from Bastian. Can you elaborate on the collaborative robots and how they work in parallel with warehouse associates? What type of efficiency gains do you get with this type of technology? So again, looking at cobots in a sense, the robots that are going to work with human workers on the floor.
Yeah, this is Derek Cribley. Yeah, I'll take that question and hopefully can answer that. The collaborative robot really is different from your conventional robot in that it operates in a safe manner. So it's got a restricted amount of load and speed, so that if a person were to inadvertently, get in the robot's path, you wouldn't injure the person. So that's kind of what's different about that. Whereas the conventional robots kind of move at very high speeds, and as a result, they require like caging, fencing, and safety systems to protect people that might get in its way. So the collaborative robot is limited then on its capacity. So you got to think about that a little bit and what types of picking items that you're picking or what you're handling may be a limit in that sense. But they can, when they think about a collaborative robot kind of replacing a person one-to-one. But because they work so much slower, I think you usually see about a 2-to-1 difference in the rate. So what a person might do versus a collaborative robot. But they don't take breaks. They don't call in sick. So there are some advantages on that side. But they are going to need to be limited to the types of products. So it's what we've seen is some operations. There'll be some that are potentially picked by collaborative robots. So if you put a collaborative robot at a station, for example, you may need to restrict what that station could do. And then the other advantage of collaborative is if you can envision like multiple robots working together, maybe one person tending the robot. If there's a problem, the person might be able to go in and easily correct the error. So that's kind of what I envision the future for the collaborative robot.
Great. It'll be interesting to watch this ride as it all happens. Certainly everyone has to figure out how to make fulfillment more efficient, cost-effective, and with limited labor, how to make that happen, and automation is a great way to do it. Thanks to all of you. Unfortunately, we're out of time for today. If we didn't get to your question, you will see on the screen contact information. You can email your question at info@bastiansolutions.com, and one of Bastian's best and brightest will get back to you with an answer shortly on any questions that we didn't have a chance to get to, or if you just want information on any of the solutions that they provided today. Shortly after our live event here, we'll send you an email reminder so you can access this presentation on demand, so you can view it again, or if you'd like to, you can share it with a colleague of yours. I'd like to again thank our guests, Matt, Derek, Melissa, and Marvin. Very informative presentation today. Lots of information, lots of things to think about. And again, our appreciation also goes out to Bastian Solutions for their sponsorship of the webcast. Again, you can find more details about them at bastiansolutions.com. Thanks to your audience for sharing your time today. We hope you walked away with some good ideas to help you better manage your supply chains. For all of us at DC Velocity, I'm David Maloney. Thanks for joining. Have a good day.